how hard is it sometimes to convince your customer that spending a little more on AI is going to get them that return on investment?
So maybe just to clarify just a bit, we were an oilfield services company, we still are, but with the GE portfolio, we're also pretty much full stream. Large turbines, gas, LNG, compression, health monitoring in my business, 1 million sensors a year we ship into the nuclear industry, the power industry, and in the oil and gas space. And then of course our traditional oilfield services and oilfield equipment business. As an OEM, really there's two ways we can approach this. One, given we have an awful large install base, both in hardware and software, we have the opportunity to help them upgrade the equipment that they have, both the intelligence, and I'll give an example, I think, 1% combustion improvement in our gas turbines gives them really about gives the world about a 2.5% improvement in CO2 footprint. So how do we get 1% improvement in our gas turbines? Hardware installation, that sounds like something that's going to take months and years. An optimized water wash based upon usage, and we talked about some of the AI discussions earlier about how we make better decisions on maintenance as opposed to a time-dependent decision, an intelligence-based decision. Those water washes are improving that efficiency on an annualized basis by almost 2%. So that's a software upgrade. Using analytics and data analytics. So a good example of, again, giving them productivity, lower fuel burn, more throughput, and lower emissions. As an OEM, I think we have that opportunity.
And I think you mentioned replatforming, right, for the majors. So if I look at the way we look at it at Shell, there is definitely pressure to have affordable solutions. So your technology investment needs to be affordable. You need to see that you can do more with less. But we are trying not to be myopic about it, because if you look at the challenges in front of us, what we need to do with transition in energy systems, that means that you have to have significant more innovation than you have now. You can't do it very effectively on the platforms we are using right now. If those platforms are disconnected, it's very hard for companies and innovators to come in, deploy at scale, integrate at scale, like Mir showed earlier. It just doesn't happen as naturally. So we want to put investment in so that we are well placed to capture that innovation value that will need to come in the next decade, right, for what we're looking at.
And Wafik, you've got a broader perspective on, where is AI in the industry right now? How much has it been adopted? Is it been maximized to its maximum potential?
Yeah, no. In IOGP, again, it's important to see we're a trade association, and our remit is to write good practices for the industry to increase performance and operation, safety, environment, energy transition, emissions. So there's a lot of things to do now with the energy transition and the digital. So it's only recently that we started working, and again, we're member-driven. We have 75% of the membership who are operators. We have 25 national oil companies, global association. And the reason is not because we're late in the game, it's simply the game needs to mature enough with operators like Shell, with technology innovators like Baker Hughes. They need to test that in different contexts, different environments, regions. What you test in the Gulf of Mexico may not be the same in the desert in Abu Dhabi or offshore. So you need to have these systems robust enough to start writing good practices. And it's just recently that we're starting to have committees trying to assess energy transition issues or engineering issues with digital. So yes, we're now being much more involved than we were in the past.
Well, I recognize the challenge because, of course, my group looks after workflows for exploration, right? And so if you look at digital as Shell more broadly, there's a lot of value that's been realized. About in 2020 alone, I think it was $2 billion of value that Shell could realize through process improvements and all of that. Now, I work in a specific side of the business that is very human-centric, right? And so we are in a space now that we have a lot of promising technologies, but we are learning how do we interpret them? How do we trust them? Where can we trust them? Where can we not? And it goes back to the trust point that we saw in the Chevron example. It's critical. Without that, there isn't really adoption at scale. And so I recognize it takes time. It takes my team way longer to build out the right trust than to just prove up that there is an interesting technology that could lead to improvement, actually.
Yeah, I think there's an important word there, trust, because, I think of the example we had with Aramco going back now about 3 years ago, where they offered their data, all their production data, all their well drill data. Even though we may have done some of the work, they shared all of the work with the 3 major service companies and said, do what you want with this. 18,000 wells over 14 years in the kingdom, do what you can do with this data. Now, unfortunately, back then, the tools like we're sitting in front of here today weren't really available on the market widely. So we spent about a year trying to clean that data, trying to understand and massage that data. But this idea that big data can't be just my control volume. If I want to optimize on a bigger scale, I've got to have data outside my control volume. And that trust piece to me, clearly Aramco demonstrated trust there, but that trust is something that really needs to be translated into data sharing in ways that most people are just not comfortable doing today still. Because you might be an OEM or because you might have a secret or you're going to be, but we recognize that if we could bring everybody in the industry up about 10%, we'd kill about a half a gigaton of CO2 just in operations in oil and gas if we just share, like we do in safety, like this discussion about the safety that we just had, which brought the standard of safety up in the oil and gas industry substantially because they did share in that space. So that's an important point.
Well, and as a journalist, getting a dozen press releases a day, and probably a third of them are touting AI in the oil and gas industry. That's kind of been the pace for years now. There's a hype cycle here where it seems, 5 years ago I was at OTC and it was going to transform the world, and 5 years later, it hasn't transformed that much. Can you speak a little bit to where we are on that hype cycle? And
I am a geologist by background, so I'm optimistic about stuff. But those of you that know the oil and gas business will understand this. But now, so the way I look at it is, yes, I remember those days. In fact, I did present at OTC as well about that at that time. So there was natural hype, natural excitement about what this was going to do. But it's just human nature. We're really bad at predicting what's going to happen in 2 years. We think that we're going to get further than we will actually get. But we underestimate how far we'll get in 10 or 15. So I think we passed that initial hype where, there's going to be this button that people press and then magic happens and everything is amazing. We went down a moment of, oh my God, this is never going to work. And then now we're back up where we see, hey, no, I see value being generated. I see exponential adoption in the company. I see that we're getting results. And so we are in a good spot. We are starting to learn how to embed this in our workflows. And we're starting to trust it more. So I'm positive about it, personally.
Scott,
but I'm a geologist.
Scott, you've got to be thrilled to hear a client say that, right?
Yeah. No, look, I think collectively we probably feel the same way about it. And I'm sure folks in the room do too. This idea that we can now collect larger data sets and do more with them and get insights from them, I think is true. I talked a little bit about control volumes earlier. When we take a mechanical system where we know the inputs and we expect outputs, more often than not, and I'll call that sort of a physics-based, physics-informed AI, we're being quite successful. We're seeing pretty accurate models. We're able to do it fairly quickly, teaming with companies like Ansys and others that do simulation and bringing in the ability to do big data. I think with a control volume, and I'll quote something I said about 3 weeks ago. I'm an aerospace engineer by training, and don't be offended if you're in aerospace, but 3 miles up is pretty common. Maybe 4, very little variability with something going to hit you in low orbit. But geology is as varied as the zip code. So if you start talking about 3 miles down anywhere in the world, there's a lot of variation. And then some of those problems are very difficult to solve with just big data. You're going to have to tune, you're going to have to get into the physics. You're going to have to understand the equipment, that control volume, which is known, and then all the things that are highly variable. And I think in those places, in this space, there's still a lot to learn and a lot to do. So I would agree, we are coming down the hype curve a little bit. We'll get into that trough pretty quickly. If some people aren't already there.
Let's drill down a little bit, because as we saw this morning, there are many different ways of applying AI. And in oil and gas, we see it with the additive manufacturing, with analytics, computer vision. Can you speak a little bit to where the greatest promise and the greatest breakthroughs are taking place in any specific area?
Well, for us, so I like to use the term home runs. There are some home runs indeed in predictive maintenance, right? Production optimization. Those are things that it's just good business, and you can see it happening. What I am most excited about, with my personal biases, right? Because again, I'm a scientist. We do subsurface evaluation. Is the fact that the data we work with is really multidimensional. And as humans, we can't really analyze it in a way that is efficient and effective and pulls all the information that we have out to then turn into actionable insights. That's where I see the most value coming in my part of the business out of AI, right? Because we just can't get our head around certain analytics, right? On acceleration of processes, all good business, as I said, they're almost home runs. But the thing that excites me is indeed this hyperdimensionality of things. How can I get insights that I really, as a human, couldn't really get out of? And that's what we see with our seismic well data, where we look at it through AI. Right?
You know, you mentioned additive, and the general mentioned additive earlier. I'm hyper excited about additive, not because necessarily of printing, because we're doing some of the similar things that the military is doing, which is given the complexity of the materials and parts that we have in our application space. The promise of additive is interesting, both from a standpoint of energy use, but more interesting when you combine it upstream with generative design. And, you know, printing 3 alloys simultaneously, or 4 or 8, which we could do physically down today, allows you to print an M&M soft in the middle, hard on the outside, without actually changing any of the topography or structure. When you add in the ability to change topography and structure, and you've seen some of these sort of webbed applications with super light parts, you know, we see 60% reduction of material. Now, why that excites me is that's not just an oil and gas opportunity, right? Aerospace is obviously leading in the manufacturing in that space, but the combination of using AI, I would challenge anybody on the planet, frankly, and get the smartest guy, Stephen Hawkins, maybe he can come in, maybe he can answer this. But to build just a simple structure like a diving board, using non-homogeneous material, we call it graded material, that on the fly I can change alloy from aluminum to titanium by the time I get to the end of the board or the base of the board, and I can input variables of the physical geometry and application. That's not going to be done by a human alone. And it's not going to be optimized by a human alone. So we're in the early stages of additive manufacturing. When we can bring generative design in multi-physics up front, additive is going to be, it's going to be even more game changer. So 30% CAGR right now on equipment and services and additive. I think that's going to go to something like 60 when we crack that nut. So there's probably not the answer you expected out of the oil and gas guy, but given the complexity of the parts that we have, from gas turbines to downhole tools, the hot and harsh conditions, and the amount of material that we use, this is going to be disruptive and continue to be disruptive for a while.
Yeah, I think from, again, the collective industry, we're more looking at it in an incremental, not so much disruptive yet. And we need to have a challenge, a problem, like emissions, CO2 emissions, carbon capture. We're also looking at AI for the equivalent of Uber for helicopter operations towards offshore. How can we make it simpler and more effective for an industry to use these helicopters rather than having only one? Digital twin is another one. Procurement is another one. But these are incremental. So I think we're going to learn through these good practices using AI to assist, to enable what we're doing already. But certainly soon it'll be disruptive. There'll be things that will come that will change our way of doing things. An important thing is that we're located in this triangle between technology, innovation, people, and process. We're essentially giving the process. A good practice is a process that links people to the technology, and it involves reskilling people to use some of these technologies. You cannot use the same engineer to use these kind of new tools or new technologies.
So the oil and gas industry is fascinating, and in some ways they share an enormous amount of information across the entire industry. At other times they hoard it like in a dragon's lair, afraid to let anything slip out. But Francesco, how important is cooperation in innovation and in advancing the industry, and where is that line between what's sharing too much and too little?
Yeah, so that's an important question that we started wrestling with in my team when we started looking at digital now a few years ago. And so the way I look at it is simple, right? So if you have to innovate at a 10x rate, like we're doing now, you need to have the ability to do so. That means platform, that means competition, that means market, that means policy all coming together, right? If you look at what we were trying to do, is okay, what is the first thing that we need to give people? Well, the data to work with and a platform where they can hook in their solutions. Well, we don't have that, right? So we said, we need to fix this. And we started doing that internally. So my team started off an initiative that we called this subsurface data universe at the time. So let's fix data for us in Shell, and let's try to make it so that it's in a platform where people can access it, so that through those APIs, we can have innovators, like Spark Cognition or other companies coming in and deploy solutions. And that should accelerate our pace of innovation. With that in place, we can also start looking at how we share effectively things like data sets that we think we can share. Because now you can say you share, but it would be really painful and manual to do so if you wanted, right? So let's do it. So we started developing this, and then you realize that every other super major person is doing the same thing. There is the Francesco equivalent on every other company saying, we should do this. And then you have 7,000 platform activities that are happening in these companies. None of them talk to each other. If you're a vendor, it's basically the same thing as before, because you have to do 7,000 custom implementations on something. That just doesn't work. It cuts out the smaller companies that might have an innovative product, but they can't afford 700 developers to deploy everywhere and support solutions across all this patchy environment. So we say, let's go out with it. Right? And that's why we started. We donated the code we had developed to Open Group, and we started the Open OSDU, the Open Subsurface Data Universe Forum, with the idea that let's come together, let's build a thing that we all use and deploy to, so that we make it viable to start competing in this space, to start developing in this space, to start innovating in this space. And so that's the angle we took. Now, has it gone as fast as I wanted? No. But we have to get better and go faster. But it's taken a lot of momentum, and there are 100-something companies in it now, right? So that's what I think is collaborating, as I said, to enhance competition and innovation, right?
Yeah. And Wafik, your organization is all about that standardization, best practices, hitting the right things.
Yeah, we're the typical example of a collaborative environment. But one has to remember that the business is co-opetition. We don't only collaborate, we compete as an industry. We cannot collaborate everywhere. So if a particular producer or operator can be competitive in a given technology that's mature, he won't necessarily want to share it with others. Unless if sharing with the others will open up another area to develop new business or competition. So it's important to see that IOGP is when all the operators are willing to cooperate to write good practice. And that in itself enables scaling up a technology. as you can see, best practices and standards, once they're defined, it opens up much more the market to increase a specific technology. So it's part of the life cycle, I think, where you have the technology, it's been proven, operators use it for competitive reasons, then they need to evolve, and they share some of the technologies that they had for good practices and come up with new technologies, new competition landscape. And energy transition is a new, very competitive area. It has to be clear. So IOGP, again, we will do good practices on things that are not in the competitive space.
You know, the demand for energy will grow. We have an enormous number of people who still don't have access on this planet to basic forms of energy, to turn on a light bulb, to get transportation to work. And at the same time, we're facing climate change. And so the energy industry is forced to take on this transition to a cleaner place. And I think listening to these three gentlemen, it's clear that artificial intelligence will play a critical role, not only in optimizing for profit, but also optimizing for the planet, and that the information is beginning to have a direct impact. We're going to wrap it up to try to get back on schedule, but thank you all for joining us, and please join me in thanking the panel for sharing their thoughts.